All right, let's deal with some tricky concepts about Chapter 18, reproductive physiology. Let's first talk about this idea of sex differentiation. And what we're talking about is the different kind of levels of sex. Remember, genetic sex is determined at the instant of fertilization, and that's the presence of either XY or XX chromosomes that occurs during fertilization, with each gamete, egg, and sperm bringing one of those sex chromosomes. The egg can only bring an X. The sperm can bring an X or a Y chromosome. XY then is a genetic male. XX, the presence of two X chromosomes, is a genetic female. XY genetic male presumes that the SRY gene on that Y chromosome will eventually start producing, for several weeks after fertilization, producing a testes determining factor, a peptide hormone. This peptide hormone converts the fetal bipotential gonads, the gonads that are undifferentiated. They can be directed either towards testes or ovaries. But this hormone, a peptide hormone, which is a product of a gene found on the Y chromosome again, this testes determining factor directs the bipotential gonads to develop into testes. So, the Y chromosome with a functional gene product, which is the peptide TDF, leads to the development of testes from the bipotential gonads. Thus, we have a gonadal male, and this occurs within the first 7 weeks after fertilization. These fetal testes, will start producing testosterone in utero. And this is remarkable in the sense that the production of testosterone is not requiring support from the anterior pituitary that we see later in puberty. Instead, again, the testes, on their own, if you want to think of it, start producing testosterone. This testosterone production leads to the development of male internal and external genitalia. And by about 10 to 12 weeks, certainly by 12 weeks or so, the internal and external genitalia has been directed towards the male phenotype under the guidance of that steroid hormone, testosterone. So then we have phenotypic sex, in this case, phenotypic male. All right, let's talk about sex differentiation from the XX or genetic female standpoint. Fertilization of an egg, which can only carry an X chromosome, with a sperm carrying an X chromosome, gives us a genetic female, XX. Thus, there's no Y chromosome. Without the Y chromosome, then, there's no gene, the SRY, and thus no product of that gene, the testes determining factor. In the absence of that peptide hormone, testes determining factor, the bipotential gonads develop into ovaries. Giving us a gonadal sex female. These ovaries, unlike the fetal testes, are quiescent. There's no hormone synthesis happening during fetal development. Because there's no androgen production, there's no testosterone production, they're ovaries and they're quiescent. With the lack of testosterone production, the internal and external genitalia is directed towards the female phenotype. And the time course is the same as I described before with the XY individual.